So I can join from laptop. Okay, someone is asking meeting ID. So you can take from the screenshot if at all you're seeing the screen, Bimal. Bimal, you're there? You can take the meeting ID here, 847, just let me type. 84796538124 and the passcode is 516785. Fine. So abstraction is the idea behind abstraction is to just do that, right? Hide the complexity of any system and provide a simpler abstraction on top of it, right? So that user whoever is making use of that particular system is really not bothered about the science, right? You really need to know how a car actually increases speed when applying acceleration, right? If it's not needed for person who uses car, right? We will really not bother until and unless you are specifically into developing something with respect to that. You're not interested as an end user, right? So that's what abstraction really talks about. Abstraction is simply like hiding the complexity of our application and provide some abstractions on top of it, right? So that a end user is not bothered about the complexity of how things are working in the backend. And in Java, we achieve abstraction using abstract classes interface. Okay, there are certain things. We'll talk about this in detail when we move forward from these OOPS concepts, right? A little more into our course, we will talk about how we can achieve, how we can see some real examples, right? And like whatever it is, right? In general, to be simply put, uh, whatever complexity that we have in our system, right? We will just try to break into more manageable pieces and then try to build some abstraction of top of it, so that it's easier for the end user to use rather than worrying about how it is actually happening in the backend, right? So just a pure theoretical, like I said, we use interfaces and abstract classes in Java to achieve abstraction, right? So we'll talk about that a little later. Okay, that's all with respect to abstraction. Now we'll talk about the next most important object-oriented concept, inheritance. So what is inheritance? Inheritance is the process by which one object acquires the properties of another object. So just I'm repeating that statement again, right? Inheritance is the process by which one object acquires the properties of another object. So this inheritance basically supports the concept of hierarchical classification, right? Like say for example, let's take something, right? We'll create some hierarchy. Let's take one example and probably understand this bit better. For example, we have yeah, let me. For example, we have a golden retriever, a dog. Okay, so golden retriever. Okay, so and on other hand, let's take example of another dog. Okay, say like say for example, poodle. Okay. And poodle is also a dog, right? It's a toy dog breed. And then I hope someone here like pets so that they understand whatever I'm just trying to tell. Next, you have another dog. Say, for example, we can take Labrador, right? Labrador, and this is also a retriever. Like you have certain objects like this: a golden retriever object, a poodle object, Labrador object, right? So, can we say all these are animals? Can we say this?
Yeah.
We can say, right? So all these are animals. Okay. So I'll just take the same box here. They'll say it as animals. So in animals, again, you have a lot of types, right? Animals, like say, for example, you have mammals, you have reptiles, right? So, yes or no, we have different types of animals, right? One is mammals. Mammals, and another is probably create another box, reptiles, right? So if you see these mammals and reptiles, they fall under category of animals, right? Animals is, this is a hierarchy, right? Animals are divided into mammals, reptiles, and so on, right? Like which among these mammals and reptiles, which classification does these Labrador, golden retriever, poodle goes into?
Mammals.
Mammals, right? So these are mammals. All these are mammals. And if you talk about reptiles, you get snakes and lizards, sort of all that, right? So this is a hierarchy of objects, okay? And I'm just taking this example. And similarly, any real world objects, they kind of fall into certain hierarchy like this, okay? Something is like superior to them, sort of, right? So inheritance comes into picture when you have model your objects into an hierarchical classification like this, right? Suppose you can have an animal class, right? And suppose that every animal class has say for example certain attributes, right? Let's take every animal will have a name, will have age, will have sex, whether it's male or female, and then weight, right? Every animal will have these attributes, yes or no? So it's not like your golden retriever will definitely have some name, age, that's a male dog or female dog, and the weight, some, right? So basically, all these are sort of attributes with respect to these attributes are common to your this also, right? Your poodle or your Labrador, everything can basically contain the same attributes, right? So same data members, like probably I would say in this way, all these objects will contain the same state, right? So in case of inheritance, I would say every animal would contain these all states. The moment I do this, all my Labrador, golden retriever, and poodle, they automatically have this state variables, right? I no need to declare them here. You got my point? In case when I have a hierarchical classification like this, I no need to declare inside each object of my dog breed, right? Like Labrador, golden. I need to, put under these attributes under here because they're already part of the super parent. You can think of this as a sub or a child objects, and you can think mammal as a parent object to these. And mammal is again a child object, and for mammal parent is animal. So overall in this entire hierarchy, the parent is animal, and mammal is child to animal, and Labrador Golden Retriever Poodle are child to mammals, right? So this is like some sort of hierarchical classification we have, right? So basically, inheritance talks about in which one object is acquiring properties of another objects. So when you have a hierarchical classification like this, right, and if you have certain attributes, certain state to your animal, so you know your mammals and its childs, right, Labrador Golden Retriever, all these mammal object, Labrador Golden Retriever Poodle, everything can actually all these things can actually acquire these properties, right? So that means this name, age, sex, weight, variables that we created in animals is available across mammals, Labrador Golden Retriever, Poodle. Okay, that's what inheritance is talks about. Inheritance is the process by which one object here, mammals and Labrador Golden Retriever, Poodle, all these are acquiring the properties of animals object, right? Because these variables are present in animals, not in these classes. So that's the reason we say that inheritance is the process by which one object is acquiring properties of another object, and this is how it supports the hierarchical classification, right? uh, if at all we don't have this hierarchical classification, no, you would put these variables across all the objects. Inside mammals you would put these, inside Labrador you would put these, Poodle, all these things, right? And in addition to these properties, suppose mammal will be definitely having any mammal would have these attributes, right? Name, age, and sex, and then weight. It will have these variables, right? And it may contain more attributes also, right? Probably your mammal contains some additional attributes specific to the mammal. Like all mammals will have some gestation period, right? So it's an another attribute, or it can be a method which is not really part of the animals, right? Or if at all like or it's part of all, I mean this attribute is part of mammals, not part of your animal. Okay, but so that means your mammals will have 5 attributes, these 4 plus in additional to this one, and this gestation period again it will come to Labrador Golden Retriever Poodle. So this will have, these things will have all these 5 properties together. Okay, and again these 3 dogs can have their own variable. Suppose they have additional variable like breed. Okay, so breed, so they can have their own variables, right? So here animals added 4 variables, mammals added 1 variable, so mammal will have 4 plus 1 5 properties, and coming to Labrador Golden Retriever, it will have 5 plus this additional breed variable which has been added across these objects, right? So your Labrador Golden Retriever, they are a retriever breeds, and then Poodle, it's a toy breed, right? So different values. So like this, you can promote reusability of your code. Okay, so like I said, right, this animals is called a parent class. It is, or it is also called as a super class, and in the hierarchy, which are basically childs directly to that particular parent class or super class, are called child classes or subclasses. So for animals, mammals, Labrador Golden Retriever Poodle are subclasses. For mammal, Labrador Golden Retriever Poodle are subclasses, and animal is a parent class or super class. Okay, so understand this jargon, guys. And how basically Java achieves inheritance is by using the extends keyword. Okay, extends, extends. Using this keyword, Java uses the inheritance concept. So we'll see some some small demo and try to understand this, right? Okay. Any queries on whatever we have discussed? Like I'm creating an animal class. Okay. Right. I think we also discussed yesterday about access specifiers, right? So what are different access modifiers or specifiers that we have in Java?
Public, private, default, protected.
Okay, that's right. Thank you. Yeah. Okay. So I'll just quickly define the data type of this. Okay. So this is an animal class and we have these variables. Okay. Now, if we look at our hierarchy, we have something called mammals class, right? So we'll create a mammal class. And it has one attribute. Gestation period. And then again, we'll create our like poodle class. Right? We create one instead of all three, right? Here it has another variable called breed. Okay, so you understood, right? We have animal class, we have mammal class, we have poodle class. Now I told you how we establish a hierarchical connection between these three: animal, mammal, poodle, right? Let's just see that, right? So we can do that using extends keyword is what I said, right? So to tie this together into at least tree structure like this, right? Poodle subclass of mammal, mammal subclass of animal. So the first thing we need to do is your mammal class will extends. We will put this keyword here, right? Extends. Your mammal class is supposed to be extending the animal class. So that means your mammal class is extending your animal class behavior, right? So because mammal is a special type of animal which will contain more attributes. Okay, that's it. Your animal is this animal class. Okay, using exteriors. Now your mammal can actually access all these variables when we connect them, both of them, into a parent-child relationship like this, right? Parent-child relationship like this, using that extends keyword. Okay, and so now we created this connection. We created this connection. Okay, now how can we create this connection, guys? This connection, how can we create?
Breed.
Mammal class is extending
Extend.
So
Mammals.
what? Yes, right. Your poodle class will extend the mammal class. Okay. Your poodle class is extending mammal. Okay. So now we created this complete tree hierarchy. Okay, this entire hierarchy we created. Okay, from animals to mammals to poodle. This entire hierarchy we created. Okay, using the extends keyword. So that means your poodle is extending mammal. That means your poodle can access mammal attribute gestation period. And since mammal is extending animal, your poodle can also have access to these variables, name, is, sex, and weight. Okay. So that's what inheritance does. Okay, it imparts that code reusability in a case where we have hierarchical classification of objects like this. Okay, right. Now you can notice the difference, right? Animal, mammal, and how mammal class can access data of animal and how poodle class will access data of mammal. It's something we will see as we go further. Okay, but this is how we create a hierarchical relationship between a set of objects, right? Like here what are the subclasses of animal here?
Mammal.
Mammal, right? And poodle is also a subclass of mammal. It is not immediate subclass, but it's a subclass, right? Because of that transitive dependency, A refers to B refers to C, then C is automatically referring to A, right? So poodle is also a subclass of animal. So what is the superclass or parent class of poodle?
Animal.
Mammal, right? So and for mammal, the parent class is animal, subclass is poodle. Okay, just understand this jargon, right? When we talked about inheritance, we talked about parent class, child class, parent, or we can also use superclass and subclass. Okay, parent is nothing but superclass, child is nothing but the subclass. So we keep using these terms interchangeably. Okay, so just remember the jargon. Okay, having said that, uh, when we use inheritance in Java using this extends keyword, right? At max, we can extend only one class. Okay. Suppose I have dog class, right? My mammal cannot extend a dog class. I can't say dog like this. It will throw an error. Okay. I can extend only one class. This is a limitation in Java. Okay. Remember this. At max, we can extend only one class, so that we have to, that's why we have to use this extends very carefully. Okay, just because you have doesn't mean you can extend any class at all, right? You have to be designing your class in such a way that, because you have this limitation, right? Why this limitation is there, we will talk, but just remember this. Okay, in general in Java we can extend only one class, so any child class can extend the behavior of only one superclass. Okay, so this is what inheritance is about. Any queries here, guys, before we move on to our next concept? Okay, so I think that's no. So now let's talk about the next object-oriented concept, polymorphism, right? So what is polymorphism? Okay, if you just try to split this name, right? Poly means poly. The name poly means many, and morphism means forms. So that means polymorphism means many forms. Many form means it is just an ability to exist in multiple forms, right? So basically, let's talk about how it basically works, right? In general, our polymorphism is divided into two things, right? One is compile time polymorphism. Let's take something. Yeah, your polymorphism, right? it is divided into two types. This polymorphism. One is the compile time polymorphism and another is runtime polymorphism, right? So what exactly is polymorphism and all, we'll just talk about it, right? So in general, I said the polymorphism is ability to exist in multiple forms, right? How we will see how it will happen in each of these types, right? Let's talk about compile time polymorphism first. So when it comes to compile time polymorphism, there are let's take this doc class for example, or probably I'll take another class here. Okay, close. So suppose let's take this example, right? Suppose I have a box class box, box class, okay, and a square can be a box, right? Yes, this is a box, a square, which is have all sides equal, and we can also have another uh, another type of box like this, right? Rectangle, something like this, right? So let's suppose our box is a parent class for both of them, right? Both square and also a rectangle like this, right? And your box will have certain attributes, like say for example, it can have weight or length, right? Length, length, height, and then width. Typically any box you take will have these kind of things, right? And if we talk about a cube in general, a cube kind of box, what is the property of a cube? Come on guys, tell me something. What is the property of a cube?
Height width is same.
Right, height, length, width, everything is basically same, right? So I can, so that means I can take one input and calculate volume of that box, right? Here int is an integer type string, you know, right? We discussed to represent a text alphabets, a text of value text, but integer will hold integer values like 1 2 3 and so on, right? Some integer values. This is the data type for integer values. So calculate the to calculate the volume of any box, say for example, I'm just taking example of this example here of cube, right? So simply the formula is I into I, right? Something like this. And your I is, it can be length, width, height, anything, right? It can be length, width, height, anything. Yes or no? It can be anything, right? So I'm just taking one parameter, but I can also use same volume, okay, same name. I can use. Now see this, I'm trying to use the same name of my another method with same name. Ideally, it will not let you create. Something has to be unique here. So here I'm changing the input. Okay. Now I'll add two more input here. Int, comma, int, length, height, weight. And here I'm changing the formula. L into H into W. Okay, see, now the errors are gone. Now if you observe, in my box class, I have a same function with, sorry, say two methods with the same name, right? And they also have same return type also, method signature, integer. But what is the difference in both of them, guys?
Different parameter.
The input parameters, right?
Yes.
This method is taking one parameter and this method is taking three parameters. So if I want to calculate volume for my cube, I will call this method, because I know for cube all sides are equal. So I'll just supply one. It can be height parameter, length parameter, width parameter, or anything, right? But when I want to calculate volume of some other box, right, which is not of cube, which may have different sides everywhere, then definitely I would go with this particular method, right? So that means I'm using same method name with a different list of input arguments, right? So this is called method overloading. Okay. So again, another new jargon. Okay. This is called method overloading. Right? And this behavior is happening at compile time only, right? So when I type, it is automatically compiling your Java program. I told you in our earlier classes, right? We need not do Java C and then box and it will create box.class. It's not like that, right? Your ID is compiling it automatically, no? So did I executed this program? No, right? I'm just typing and your ID is generating box.class file in the backend. So if there are no errors, only it will compile properly. Here there are no errors, so it's compiled successfully, right? Suppose if I try to put a one method, then it throws an error, because the error, everything is happening at compile time. I'm not actually running this method, right? So this is what compile time polymorphism means. Okay, when you are trying to resolve conflicts within the compile time, that is called nothing but a compile time polymorphism. And the example of compile time polymorphism is nothing but method overloading, where we will have a same method name. Okay, same method with multiple methods with same name and different set of input arguments, right? So why we will do this? Just to promote that reusability, that's all. Okay, so that we know we are trying to call different methods. Our purpose is to calculate volume, right? But different set of boxes have different types of inputs, right? So that's the reason we are doing it this way, right? So this is called a compile time polymorphism, and example of this is method overloading. Okay, and coming to runtime polymorphism, here you have something called method overriding. Okay, and this also have another name called dynamic method dispatch. Okay, so your compile time example is method overloading, DING. Okay, and your runtime polymorphism is method overriding. So understand the difference. This is overload, this is override, and the another example for this is dynamic method dispatch. So what exactly is this? We will just try to understand. So runtime polymorphism comes into picture in case of inheritance, when we have hierarchy like this. Suppose your mammal has certain method, for example, right? Let's say for example, it has certain method like say what, like hunting skills, for example, right? Hunting, like hunting, or probably I'll take, yeah, hunting. Okay. Some method like this. Okay. So when your dog is a not dog, when your poodle is extending animal, right? Yeah, when your poodle class, sorry, I'll take the poodle class. Yeah. So when your poodle class is extending mammal, that means not just methods. It can also, your poodle class have access to this hunting also, right? Suppose your poodle also has its own, poodle has a different set of hunting skills. For example, like your all mammals will have some hunting skills. They have some skills, but your poodle is a breed which will not do any hunting, right? No hunting skills. It won't have any hunting skills, right? So if you look at this scenario, right, your poodle will automatically make use of hunting method in mammal because your poodle class is extending a mammal class. Your poodle is a subclass of your mammal superclass, and your poodle also has another method, hunting. So when you try to create an object of poodle class and try to call hunting method, which one will be called? This no skills will be called or have some skills will be called? What do you think, guys? Now, you understood the confusion, right? In case of hierarchical configuration, your parent class has one method and you have a same method with the same name in your child class also. And when you are creating object of your poodle class and you are trying to call that hunting method, which one it will call? It will call the no skills method or have some skills method. What do you think?
No skills method.
No skills method? Are you sure?
Yeah.
Any other answers? Why not have some skills method in the animal class? Because it is also hunting method, and when, like I said, right, when poodle extends mammal, whatever properties that are there in mammal, be it the variables or methods, everything will automatically become available to poodle, right? Like I'll just give you an example. Probably I'll try to create one more class, like say demo. Okay, here, okay, I'll say main method. Okay, now I'm trying to create a poodle class object. Okay, so this is how I create a poodle object using, look at the syntax, it's different. It's pretty early to cover, but just remember this. You use something called new keyword to create a poodle object. When you say like this poodle class is actually stored onto the memory. Okay, so using new keyword. So when I say p dot, like see, it has hunting method, right? Suppose I remove this hunting p dot hunting. Okay, I'm calling this. Now my question is, this hunting method belongs to poodle class, poodle hunting which has no skills, or mammal hunting which has some skills, is my question, right? If you see, like I told you, poodle will automatically have objects of or members of mammal class, right? So let's see if we can access gestation period using poodle object, right? P dot, it has this gestation period, see, which belongs to mammal. Okay, like say 20 days, for example. You see, right, does poodle class have this gestation period? No, it's part of mammal class. So that's what I mean. Your poodle class is actually getting the properties of your it's a super class, which is mammal class here, right? So similarly, what this hunting can be. Now this is an ambiguous situation, yes or no, right? For us it's ambiguous, which class it will call, which class it will call, yes or no, right? or let's, you got my question or not? Guys?
Yeah, I think the JDK automatically picks the hunting from the poodle class.
Yes.
That's what.
So, see, that's true because of if I'm assigning the object like this, right? Suppose let me try to create a mammal object like this. Okay, mammal m equal to, I think whatever you guys said is true, but let's take an example. So your Java compiler JVM will decide that at runtime, okay, because your method is, your child class method is overriding your mammal class behavior. Okay, your mammal class have some skills, whereas your poodle class will have no skills, right? So that whenever you define the same method which is present in mammal class within poodle class, and you gave here a different implementation, here you are saying it's no skills, that means this have some skills will be hidden. Okay, it is overridden by your poodle class. Okay, that is why we are saying runtime polymorphism will override the method implementations. It will not overload, it will not complement it, it will modify it in case of runtime, whereas in compile time you are complementing it, right? Both are coexisting at the same time, but here it's not possible because of the conflict that we have, because of same method name being used in the superclass and subclass, right? So your subclass will basically override the behavior of your parent class, right? So whenever you call p.hunting, it will always be no skills only. Suppose this method is not there, for example, right? So still p.hunting is working because it is mammal class is superclass of poodle and mammal have hunting method. So now in this scenario, it will directly call mammal hunting method because there is no concept of method overriding here, because there is not same method present in poodle class with same name. Okay, but why, you may ask me why I have to do why I have to put same method name in my child class? Why can't I use different method name here, right? Again, to promote reusability, right? Suppose your mammal will give you some implementation for hunting. Okay, then your mammal subclasses like poodle, retriever, they may have their own hunting mechanisms, right? So they can add some more behavior to hunting, whatever mammal is already providing you. Again, code reusability here, right? Now if I just put syntax in this way and I say m.hunting, here which hunting method, what is the output here, guys? In case of p.hunting, I think you said, right, no skills. Here what is the output? m.hunting,
Have some skills.
have some skills. Okay, now I'm coming to the actual runtime polymorphism, how it will work, or dynamic method dispatch, right? Now here I'll say poodle. Look at the difference, guys. Okay, I'll say here m1. Look at the difference here. Poodle for poodle reference p, we are creating poodle object only. Here for mammal reference m, we are creating mammal object only. But look at here. For mammal object m1, we are assigning poodle. This is possible because poodle is a child class of mammal. If this extends keyword is not there, for example, it will throw an error because this is not allowed. Okay, so that means we can basically assign the subclass objects to the superclass references. Okay, subclass objects we can assign to the superclass references. See, this is a bit confusing. Now I'll say m1.hunting. Now tell me here what will be the here, no skills or some skills, what will print?
No skills.
No skills. Anyone? No skills. Are you guys sure? Why not some skills?
So it's overriding.
Okay. Anyone thinks some skills? If so, why?
No skills.
Okay. Everyone thinks it's no skills, right? Anyway, right, that the answer is true, because if you see the object we are trying to create is poodle object. Okay, so which will take this overriding method rather than this method. Okay, this is called, this is the example of runtime polymorphism or dynamic method dispatch. Okay, so this is what polymorphism is in all case. And when you attend Java interviews, in every interview, at least in the beginner Java interviews to intermediate Java interviews, or even in advanced Java, in probably in beginner and intermediate Java interviews, they will ask you this question like 99%. Okay, in like in advanced Java interviews, at least they'll not ask you everything, but they may ask you also. Okay, so this is a very important question. They'll ask you what is polymorphism, right? You will tell them compile time polymorphism and runtime polymorphism. They'll ask you what type of what is dynamic method dispatch. They'll talk about, they'll ask it indirectly. Then you can tell it is nothing but a method of overriding, right? When your sub parent class and subclass is having same method, so your child class is basically method with same name, right? Your child class is basically overriding the behavior of your parent class method, right? So that is called method overriding. And at the runtime, depending on the object you are assigning to your reference that you are creating, it will automatically resolve to a certain method that is called as nothing but the dynamic method dispatch. All this is happening at the runtime, right? It is not happening at a compile time, right? So I see at this moment, it doesn't know. When I say m1.hunting, at this moment, your Java JVM doesn't know which method to call, whether this poodle or mammal, right? When the program is actually executing, that's when it will resolve to this particular method. Okay, understood, right? So that is why it is called as a runtime polymorphism. So this is really an important question with respect to interview standpoint, guys. So any questions? Else I would explain this again. So I think with that we pretty much finished our object oriented concepts. Okay, any questions here? Any questions, guys? I'll stop here for today. Okay.